Hello and welcome to Advent of Code 2024, day 19. So it's called Linen Layout. So today the historians take you up to the hot springs on Gear Island. This is the Gear Island from last year's EOC. And very suspiciously about nothing goes wrong as they begin to careful search of the vast field of helixes. Yeah, so our protagonist can now finally be able to visit the onsen next door. And after a brief conversation with the reception, they will let you in for free if you can arrange their towels. And every towel at this onsen is marked with a pattern of colored stripes. So we see here that they have a white pattern, they have a blue, black, red, green. So a towel with the pattern GGR would have a green stripe, and then a red stripe, in that order. So as the order is very important in this puzzle, because it says here you cannot reverse a pattern by flipping a towel upside down, as that would cause the onsen logo to face the wrong way. So the official onsen branding expert has produced a list of design, each a long sequence of striped colors that they would like to be able to display. So you can use any towels you want, but all of the towel stripes must exactly match the desired designs. So to display the design RGRGR, you would use two RG towels, then an R towel, then an RGR towel, and then a GR towel. Or even a single massive RGR towel. So our puzzle input will look like this. We will have our kind of patterns up here, and we will have our designs here. So the designs are possible designs, so to speak. And what we need to do is to basically check our pattern, see if we find matches within those strings for patterns in these. We need to remove them from the design and check the rest, and exhaust the entire list of patterns. If we can fill the entire design, then it's available. So we can see here in the example here we have a pattern, or we have a design that says BRWRR, and that can be done with a BR towel, then a WR towel, and then finally an R towel, and so forth and so forth. And in this example, we will have six of these 8 designs are possible. So how many designs are possible? Yeah, so this is the test input here. So we will begin with parsing our input, of course. So we will have our input, which will be our file that read all text, actually. So we will take test input, and we will parse by, can write, parse by no, not parse, of course, split by W line. as we saw in the input here, we have a kind of a double new down here. So we want them in, we want to extract two parts from this input. So we will have our patterns will be our input 0, and those will just be split by kind of a comma blank space, and then we will make them into a hash set. Then we will have our designs, which will be our input 1, which we will split by a new line. So now we have our design, we have patterns and designs. We will have a counter for our available designs, which will be 0 at the start, of course. So yeah, so we need to make this to do this. We need a method for this, because the most effective way to do this is to do it in a recursive pattern. So we will have our method that will, in this sense, we will return bool. So if this design is possible, so call it this design possible, and that will take in our design as a string. We'll have our hash set of string, will be our patterns, and we will also have a dictionary, memorization dictionary, where we will store. This is just done for optimization, because we don't want to check strings that are already calculated before. So that's why we keep a dictionary. When we search a pattern, if that pattern has been searched before, we will just return the value for it. So we don't have to, because this kind of recursive method could give us very bad performance if we don't make the pattern correct. Yes. So we will begin with actually taking checking the memo. If it's null, we will just do a new dictionary so that we initialize that. If the design is empty, then that means that we have already exhausted it, and that means that we have a valid design. So if it's null or empty, then we just return true. If the memo dictionary contains the key, and that key will be our design in this sense, then we return the memo, return from what's in the memo. That will also keep us from doing further recursive checks down the line. So we do for each over our patterns. Oh, patterns. Pattern, yeah. So, so you want to check always from the start of the design. So if the design starts with the pattern, that for instance we can kind of check this. So if you take this one, for instance, we will begin by checking this. This will probably be our first pattern to check. We will see well, now it doesn't start with that. 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 It's not until we are here. Okay, we find this. Okay, then we know we can go on with it. So if it starts with this pattern, we will kind of slice off that pattern and the remaining. So the remaining remaining will be our will be the design where we will take pattern length. So we will slice off that pattern from the beginning of that string. So then we have the rest to work with. And then we will do our recursive jump. So if is design possible, we have the remaining, we have the patterns, and we have the memo. And if it's possible down the line, we will store it to the memo. Set it to true, then we will return true, and in the end we will if we don't find anything, we will set the memo that design will be false, and we will also return false. So this is basically our, yeah. I'm not going to do that. I'm going to do that instead. So in this so now it's the only thing left to do now is to for each designs, and if is design possible, design patterns available will update, and we will have our part 1 answer. So let's test this out. And we have 6 here as a result. So let's get back to this. So it's 6. So this is pretty straightforward actually. So part 2 is actually a variation. So what I now need is for you to do is to kind of check all available for each design. So that, let's say that this one here can be made in 2 different ways. So it can be a BRWR R or BRWR and so forth. So now we need to kind of make a method that instead of just checking if it's possible at all, we will check how many ways it's possible, basically. So we can go back to our code now. We will have a new method. So we will call it static. It will be a long. Let's say count all pattern ways, maybe. All pattern ways. So this will take in our string design. This will be our hash set of string patterns, and we will also have a dictionary of string, but not bool this time, but so we want to have the count this time. So we begin by initializing our memo. We will check if, yeah, I mean, we can take some count, some. It's basically the same thing that we do here. We will obviously not, we will try to return 1 in that sense, but so we will also have a kind of total ways. We want to count them. So yeah, for each pattern in available patterns, yeah, we will actually do more or less. It's the same thing as the above method. It's not that many changes actually. So we will still do the yeah, we can actually take this and just modify it a bit. So we will start with, we check if we start with a pattern, and then we will take away this, and we will say total ways plus equals count all pattern ways, and that will be our remaining, and the patterns and the memo as before. So that's and of course the if we don't find anything, we will always return total ways, and we will set our memo to the total ways as well. So now we will have our we will basically do the same thing. We will just kind of reset this to 0. We'll do for each of all the designs. And then we will collect how many ways from the count all pattern ways, design patterns, and we will kind of update our available with number of ways, and this will be our part 2 basically. Yeah, so if we run this, we got 16. So that was what was in our test data here. So now I'm actually going to show you the a little improvement to this, because I can actually just show you when running with my real data. That part 2 will actually take a while. Kind of runs, you can see, because there are long strings and you get this big value here. So the way I mean, obviously you don't have to do this more optimization if you don't want to. It's probably not that necessary. You can probably do it kind of in just keep it like this, of course. But I thought it was a little bit fun to just see how fast I can make it. So let's just we're going to keep track of the performance of this. We will kind of have a stopwatch. So we'll check. So if we now run it, we can check the part 2. Oh, it's really slow now. Yeah. So running this slow will before when I checked it was around 3000 milliseconds, but right now I'm running on battery on my computer, so it might be a little poorer performance by that standards. But we will, I guarantee you, we will make this almost instant. So how can we do that? Well, just for example's sake, I will actually create a new method here. Obviously, you will probably not do this. Keep the slow method in your solution, and I will not keep it in my solution either. But I just did this for the video's sake. I think it's nice to show this. So we begin with the, because what we want here, what the problem here is actually, is that we're checking every possible pattern against every possible design, and the patterns are of different length. So it doesn't make sense actually to check a design if the pattern doesn't match. And So yeah, so we need to actually have a method that sorts the patterns by its length. So we will so this will actually output a dictionary of int and the list of string, which will be our patterns. So the int will be the length. So we call this sort patterns by length. And this will take in our hash set of string, which will be our patterns. Yeah. So we will we'll have our new yeah. Yes. So we will have our patterns by length, which will be a new dictionary of this exactly. Then we will do a for each of patterns. So for each pattern, if not pattern patterns. Yeah. So it's not contains key, which will be the length of this pattern. We will kind of new this up, and then we will do the patterns by length with this pattern length equal, and we will kind of add this pattern to that. Yeah. And yeah, that's it. So return our patterns by length. Yeah. And yes, so now we have that. We will kind of then we need to have our new method. So we kind of let's just call this static long count of pattern ways. We can actually call it, no, we will just call it 2 for just to make it more clear. So it will be design, it will be a dictionary of which will be our pattern by length, which will be a list of string patterns by length, and it will also have our dictionary, the memo dictionary. We can just copy that. Yeah. So let's see here now. So we will yeah, we can actually take take most of this. We can copy this part to this. That will be the same. Then we will kind of also have, yeah. So we will have an outer for each around this. So it will be for each. That will be our length in our no, well, now I'm actually changing the original method. That was not what I wanted. Okay, we copy this in this as well. Yeah, so we will have our, yeah. I will actually. Now I can see that this is slowing down my performance. So I will just change to plug in my power cord so I can do this. Then the sound will be a little bit. It will not be as good sound, but yeah, we will make it work. Oh, I see. I don't think you heard anything what I did, but yeah, as I just gonna repeat it. So I just added this kind of for each loop around this other for each, because I want to match the length of the design so that we don't check any patterns that doesn't actually match the length of that design. So and also we have also I kind of added another performance which actually could, I'm not sure if this actually is needed, but instead of doing starts with this pattern, we would do we will call this method instead. So So we will say is pattern match. Does it match the design and pattern and length? So doing this will actually make this a lot faster. And just as a recap, we can run it now. It will probably not take 7,000 milliseconds now. It will take somewhere from around 3, I'm guessing. Yeah, 3,000. Okay, why? Yeah, I can show it twice there. Yeah, so it was 3,296 milliseconds. So let's add our improved performance thing. So we will reset our available and also our stopwatch. Then we can have our sorted patterns, which will be sort patterns by length. So now we have it sorted. Now we're going to start our stopwatch. We have our for each design and designs. Pattern ways 2 with the same or almost the same. So we supply our sorted patterns instead. Yeah, so that will be it, and we will stop our stopwatch, and we will have our output part 2 again. So let's do this. Let's see what performance boost we can get from this. So now we have our 3 millisecond, and wow, 122 milliseconds. So yeah, we will obviously take this one, I'm guessing. So well, this was kind of a little bit of a detour in this video, and I will push this to my GitHub, and the link to my GitHub you'll find in the description text below. Yeah, well, see each other. Well, tomorrow it will probably be a video. I'm not sure that I will do a video tomorrow. Maybe I will not have the time because I will also not do the puzzle in the morning as usual because I will be away. So maybe the next video will come out Saturday, and that will probably contain both day 20 and I will do or not 2, but I will probably do day 20 and day 21 on Saturday. Yeah. So see each other in the next video then. Bye bye.